I have one or two things to do.
If I could ask everyone to take your seats.
How about you?
I was in Pittsburgh.
Thank you for those of you who are complying.
Oh.
And
well done.
Then I'm going back to, I've got to teach tomorrow morning.
Oh.
In the eyes
thank
of the
you.
United
That's very
Airlines.
helpful.
I haven't left Dulles Airport because they gave me.
Okay, well, just in the interest of time, because we do have a packed agenda, and a number of people have already said we'll need to be here longer than we plan to cover all the topics we plan to cover today. I just want to make sure we get started on the second panel, which we got a nice preview to in the last panel on competition about the role of nuclear in a carbon-constrained world. Again, I'm Sarah Ladislaw from the Energy Program here at CSIS, and I think I'm on a stage with people who need no introduction, but my job today ostensibly is to introduce panelists, so I'm going to do that. One of our first panelists all the way on the end is Michael Greenstone, who's the Milton Friedman Professor in Economics, the director of the Becker-Friedman Institute and the Interdisciplinary Energy Policy Institute at the University of Chicago. He previously served as the chief economist for President Obama's Council on Economic Advisors, where he co-led the development of the United States government's social cost of carbon, which we'll talk a little bit about in a minute, and on the Secretary of Energy's advisory board. He once worked for the Hamilton Project as well, and is an elected member of the American Academy of Arts and Sciences as well. So, and then right to my immediate right is David Victor, who's a professor of international relations at the School of Global Policy and Strategy, the co-founder and the director of the Laboratory on International Law and Regulation at the University of California, San Diego, and a senior associate here with us at CSIS. He's worked before at Stanford, where he taught energy and environmental law, and he focuses on regulated industries and how regulation affects the operation of major energy markets, something that applies to our discussion today. He's also a lead contributor to the IPCC and was recently tapped by Southern California Edison to lead the company's community engagement panel on the decommissioning of San Onofre Nuclear's power plant. So I know most of us have been at, welcome guys, thanks very much for being here.
I just have to apologize. Yes. This is an extremely well-dressed crowd. I didn't bring a tie.
That's okay.
In California where I live, putting on shoes means it's a formal event, and so I feel like I've dressed up.
Well, we appreciate that you have shoes on.
Don't worry, we all feel overdressed.
So I know we've all been at conferences, and we really just kind of got into one of the symptoms that happens at these nuclear discussions, which is, you know, what are the things that could change the competitive reality for nuclear power? And a carbon constraint is often cited as one of the main reasons that nuclear could provide additional value. And quite frankly, the nature of the climate challenge being such as it is, could provide the kind of driving impetus to launch the kind of efforts that you heard talked about in the last panel for the US to really sort of up its game in terms of nuclear power, and for other countries around the world to do the same. We thought what we would do is start off this discussion about the ways in which the carbon constraint can actually make nuclear more competitive, and the ways in which maybe it doesn't, with some level setting. So I'm going to turn it over to Michael first, and who's going to do some level setting on the economics of nuclear relative to other fuels, and sort of set the scene for us. And then David's going to do the same. We started out with an aspiration of no slides, but you know, since we're the only ones using slides, we figure we'll take the luxury and provide a few of them. So Michael, please get us started.
Thank you. It's my pleasure to be here today. There we go. So words make me uncomfortable, and numbers give me a certain sense of safety. And so the purpose of this talk was to just do a little level setting on what some of the numbers are, although honestly, although it was in words, the last panel covered several of the points, so maybe this will just clarify a couple of them. So you could pick your favorite climate mitigation scenario. Here, I just picked 3 from the IEA, something that's better, less temperature increase than 2 degrees, 2 degrees is the blue line, and something that's like the Paris Accord, making some assumptions about what will happen. And all of them involve substantial increases in nuclear technology, the deployment of nuclear technology. And you can see maybe as much as increasing it by the current capacity by maybe 2.5 times. So that's embedded into all climate scenarios. We can come back and talk about like how engineers do that, and we could probably spend a lot of time making fun of engineers, but that's a starting point. Strangely, while that's projected for the world, the United States operating capacity is expected to decline dramatically over the coming decades. That's largely because we haven't been building any nuclear plants in any meaningful way for quite a while, and the licenses for the existing ones are set to expire. Now, I think in practice, there would not be such a precipitous decline. Many of the plants will be extended. But if you just took at face value their current licenses, at the very same time the carbon constrained world is supposed to produce reductions, increases in nuclear deployment, in the US it looks like the opposite is happening. So why is that? And this really totally was embedded in our discussion, or in the discussion of the last panel. But again, I'm going to just try and put some numbers on it so it's a little more fine-tuned here. So what I've done here is calculate the cost of building a new plant that would be open in 2022 for a bunch of different technologies and the cost that it could produce electricity at and earn a reasonable rate of return. And there's the top three are the kind of three major current baseload technologies: a conventional coal plant loaded up with required environmental abatement technologies, a combined cycle natural gas plant, and kind of the standard technology that we're using for nuclear in the US. And among those three, you can see that due to the fracking revolution, the combined cycle plant is the winner by far. If you wanted to buy electricity from a nuclear plant, which we actually, I would argue, don't even know the real price in the United States, it would be almost twice as much. Now, as a comparison, since this is about in the constrained carbon future, I put up what I'm going to call 3 Frankenstein plants, which are renewables with natural gas backup. Because at the end of the day, something is going to have to operate when those guys aren't running. And you can see that those are also more expensive than natural gas, and it just reflects that the world is awash in natural gas. Okay, so now we're going to do 2 big reveals. The first big reveal is we're going to try and take this idea that's floating around in the room and implicit in the purpose of the panel, that wait a minute, carbon might be bad, and maybe there's an externality associated with it, and we should have a price associated with that. And let's see, does that like tilt the playing field at all? And does that bring our beloved nuclear closer to being in the game? And so if you apply, and you should listen to me very carefully here, if you apply the United States government's social cost of carbon, which as Sarah mentioned, I helped design, and applied all 8 years of the Obama administration, it is unclear what the social cost of carbon is currently in the Trump administration, although their signals are that
zero.
I don't think they want to go to zero because they have to fight a court case, but single digits. But if you took the Obama number, it'd be about $50 per ton of CO2. And if you applied that charge to the fossil fuels, you can see that actually nuclear starts to look like it's closer to being in the game. You can also see that that coal would really be far out of the money at that point. And then you can see, you can almost see in the case of hydro, but for the others, you can see what the cost would be for the renewables. And it's important that you see they get green bars too, and the reason they get green bars is because they're using natural gas to back themselves up. Okay, so that's one big reveal. So that starts to change things. It suddenly looks like, maybe nuclear is not so far out of the money. And then you can add into that, well, remember, a lot of the fossil fuels have health problems associated with it, particularly particulates and premature mortality. And how does that change things? And since natural gas is so clean, it doesn't really increase the price of natural gas very much, but it does kind of, it's like, it would be the end of coal, per se. Coal would be way out of the money. And I want to emphasize, just because that charge doesn't exist now does not mean we're not paying it. We're just choosing to pay it through higher risks of climate change and higher rates of sickness and things like that. And so as level setting, what this is meant to say is we can talk about how we like nuclear and how much we want nuclear and things like that. But that's just talk. And until the market is structured in a way that it reflects the externalities associated with other technologies, we're just talking, kind of Starbucks talk. And to really make nuclear and other low carbon technologies a real participant in the marketplace, you're going to have to somehow price these externalities, which we are all paying just right now, we're paying them indirectly. So I think there's some real pessimism, I think, about the current nuclear technologies. And we're trying to learn a lot about small modular reactors and Gen 4 and high temperature ones and sodium cooled ones. And what the blue range there is meant to show is we don't actually know what they're going to cost, but that's kind of a range of reasonable estimates of what they might cost in 2040. And I'm all in favor of investing in lots of R&D to try and find out where in that range we're going to land. But it's important not to forget that the hurdle that they're all going to have to jump over, I think, is basically natural gas. And just so you can see, none of them, even in the most optimistic scenario, are going to jump over natural gas in the green line, where we don't reflect externalities. But if we put in externalities, then these new nuclear technologies, there's some probability that they would prove to be good. So now the last kind of fact setting that I'll add to this is, well, are we doing the things that you would do if you wanted to learn where in those bars we were going to be? And I think the answer, this is plotting global nuclear energy R&D by year. I think you'd be hard pressed to look at this and say, you know what, this is a serious commitment to find out if these alternative nuclear technologies, next generation ones, are going to be able to participate in electricity markets. So that's my level setting.
Great, okay. And so, well, David, you're going to do a degree of level setting, not on necessary LCOE, but also on the political economy of nuclear.
Yeah, I think the scene that Michael set here is really important, because I agree with a lot of what was said in the earlier panel. I was a little concerned about the kind of tone of it has to be here regardless. It has to be here if it can compete. And bringing the externalities in is part of that competition. So I guess before I make a few remarks of setting the politics, I just want to say I am completely sympathetic to the mission of keeping open the option with existing fleet and with new build around nuclear. I've just rotated off the EPRI board. Almost half of our R&D at EPRI is in nuclear. I'm on the advisory board at INPO. I want to make the existing fleet as operationally safe as possible. I'm spending all this time on San Onofre, which is a political gift that keeps on giving, I guess. I mean, just the kind of capacity of people to disagree about almost anything is extraordinary. But we have to find a way to decommission reactors as well. So I'm completely sympathetic to this mission, but I have to say there's kind of a whack-a-mole feel to the whole conversation about what keeps nuclear alive. For a while it was load, and then that went away. Then it was high gas prices, that went away. It's this, it's that, and so kind of the current episode of whack-a-mole is carbon. It's going to be here so I think this is the strongest mole to whack, as it were. But it's not obvious that carbon automatically brings nuclear into the money for the reasons that Michael said. So I just want to say a couple things, but actually it doesn't.
Point it directly at it.
There we go. No, it's moving.
Watch this.
I told you.
I don't know how to do it.
There you go.
We have a very temperamental.
Okay. Okay, thanks. I just want to say four things very, very quickly. I think it's crucial when you think about both the economics and the politics to separate the existing fleet from new build. So this is a terrific paper from Roth and Jaramillo published recently that on the top shows the single reactor sites and on the bottom the multi-reactor sites, and it echoes what we see in the market already. And what they've done, and that's new in this paper, is they've calculated the implied carbon cost in the kind of subsidy that would be needed to bring each of these individual reactors back into competition with natural gas at the margin. Natural gas is the key to understanding the competitiveness. Everybody in this room knows that. And for the existing single reactor sites, the numbers are in the kind of $50 to $100 range. That's a big number, compared with policies that seem likely. But for the competitive multi-reactor sites, the numbers are a lot smaller. They're $15 to $30 a ton CO2. They're totally within the range of policies that are already being adopted by many different states and localities here in the United States. They're well below the numbers that Michael's put together for social cost of carbon. And so I think for the existing fleet, especially the more competitive ones, many of them are going to survive anyway, but the carbon case, this is one of the most cost-effective carbon policies at the margin. So that's the first point. And I think the politics of that are going to be pretty straightforward.
These are the existing ones.
These are the existing ones.
Yeah.
So what we've got here are individual units and then their estimate of what their actual and operating costs are and so on, compared with what we see in terms of actual power prices today.
Yeah.
The kind of benchmark power price of the U.S. is in the low $40 per megawatt hour. And many of these existing reactors are not competitive, and we see that in the newspaper all the time. So that's the first point, is for the existing fleet, the carbon prices are a really totally different story from new build. The new build picture is just really different. And I think you could imagine scenarios in which new build is in the money. Michael laid those out. I won't reiterate that. This is from a study just published about 2 months ago by EPRI, a really terrific study that looks at the potential new build in the United States under different scenarios with advanced reactors, where they vary the capital costs potentially down to $2,000 a kilowatt overnight, which sounds like a really small number. I mean, it is a very small number. It's South Korean numbers, it's Chinese numbers, and so it's kind of within the range of what we see already inside the industry, and potentially plausible future. And the message from this first is that in a world of low gas prices, you get nothing. Their low gas price scenario is basically $3 forever. We live in $3 forever right now. The world is awash in natural gas, and so, I mean, it's a really, really sobering. When you use the reference scenarios that come from EIA, you end up with these high gas prices, and I think they're just going to be wrong. So that's a big problem. You see a lot more nuclear build in their world when you put in small carbon prices or you put a cap on emissions. And the scenario they're looking at, which I think is very interesting for this room, is capping emissions from the power sector at 95% below current levels. There's a very, very strong result in the energy modeling community that a world that decarbonizes is a world that electrifies. And so all else equal, you typically expect to see the power sector absorbing most of decarbonization, and other parts of the economy, transportation in particular, less so. And so these 95% reduction scenarios, 95% is a big number, but you start to see a lot more nuclear additions. So that's kind of consistent with our intuition, and it's inside the money compared with other kinds of competitors. There's some discussion earlier about renewables. I'm sure we'll come back to that. The third of the four things I want to say very briefly is about the global picture. And this was discussed a little bit, more than a little bit in the last session. I just want to remind everybody that the rest of the world is already building, without worrying about carbon, is already building actually quite a lot of reactors. So this is the IEA scenario, the new policy scenarios, and not as aggressive as the 2-degree scenarios that Michael showed there. You see significant, not overwhelming, but you see significant nuclear build out, half of it roughly going to China. Already the reactors that are being built and planned in China are equal to all the rest of the world combined. The Koreans are probably the world's leader right now. We talked a little bit about the Abu Dhabi experience in the previous panel. So this is happening automatically, and what you're seeing is a gap growing between the US fleet, which is in kind of midlife, I guess 50 is the new 30, but in midlife and declining quickly with the questions about extensions, and a lot of younger reactors being built in the rest in the rest of the world. So I think that's a very, very important thing for us to keep in mind, because it could well be that many of the innovations in the rest of the world are going to then, in some sense, reverberate back here. The last couple of things I just want to show before I stop is this is from the Lovering et al. Paper from 2016, which shows overnight capex for nuclear reactors built historically by the year construction began. And so you see this big spray of blue dots. Those are the American reactors begun largely in the 1970s, up to $10,000, $11,000 per kilowatt overnight, kind of toxic numbers. But then you see the recent reactors being built, principally with the South Korean experience as the lead, really anchored around $2,000 a kilowatt. And so we're seeing in the rest of the world real reactors being built by real adults, with state-owned firms and risk management, some of the things we were talking about in the previous panel, but at reasonable numbers that work without carbon, and you add carbon to the equation, and it becomes that much stronger. So my kind of summary of today's problems are that in the emerging economies, there's actually quite a lot of building going on, and there are some technical and operational problems, and they're being solved, you know, with the caveat that we don't really know what's going on inside China, and we don't really know how well the operational safety issues are going to scale up. And in the mature industrialized economies, most of the problems are really not problems with simple engineering solutions. They're problems that have deep political anchoring around them that are going to be very, very difficult to solve. And so one of the concerns I have is all this talk about small modular reactors and new designs and so on, is that I don't see those reactors actually having a niche where they get started, because they're going to have a hard time in this country, and they aren't really needed, I mean, outside of the Kenyan grid and so on, they aren't really needed for most of the new build in the emerging economies. And so it's harder for me to see in the case of small modular reactors the kind of boomerang that we saw with, for example, solar cells, where the Germans spent a ton of money building what they thought was going to be a German solar industry, and they ended up building a Chinese solar industry, but brought down the cost of solar for everybody in the rest of the world. I don't see that right now poised to happen in the case of small modular reactors. And the fourth thing I'll say just to close is about the choice of policy instrument. We love to model this as a carbon tax, and I love the competition and the idea of allowing all the different sources to compete. When you think about this from a political economy point of view, as opposed to what's the right policy instrument from a kind of analytical perspective, we're not seeing those carbon taxes hardly anywhere in the world. And what we're seeing is in the places in this country, for example, that are trying to protect nuclear, we're seeing instruments designed specifically for nuclear, and then at the same time instruments designed specifically for renewables. And we're torquing and distorting the economy in various ways with this. And I think we're all horrified when we see this because it's bad policy instrument design, but I think politicians know exactly what they're doing. That they're designing these instruments to favor politically very well-connected groups, and to make it harder to figure out what the real cost of the policies is. And that's a problem for nuclear, because we don't have a decarbonization coalition in this country. We have a renewables coalition. We have some other bits and pieces of micro nuclear coalitions in particular states. But the renewables coalition is not the same thing as a decarbonization coalition. And so I think it's actually quite likely that we're going to end up underinvesting in nuclear compared to what would make sense, even if we take decarbonization seriously.
That's great. Okay, so you both have put a lot on the table that I want to sort of systematically go through, and starting with your last point, David, and Michael, I'm going to ask you to comment about it. So we have this tendency to say there's a climate imperative, and you can analyze it on various time levels. You're either looking at the here and now and whether you can reduce emissions and how we're doing in terms of year-to-year emission reduction now. And then there's the system transformation 2040, 2020, somewhere out in the future but not today, estimation of where we're going to be and technologically how we get there and what are some of the policy designs. But the politics around it, which have real economic implications, which you just talked about, play out a little bit differently, right? Which is, we're talking about the existing fleet here in the United States. There's an argument that you have to keep it intact because if you don't, you lose a whole bunch of zero carbon or near zero carbon electricity supply here in the US. But are the when you don't look at it from a, hey, we have to keep nuclear going, so on a system-wide basis, this makes a lot of sense, and just look at it from a market perspective, do the kinds of policies that you're, if I want to put a word in your mouth, that you're called more tribal than sort of economic, the kind of policies that are being put in place to try and keep existing nuclear open, do they have these sort of distortionary effects that you had just sort of brought up? And what are those? And are there costs and benefits to the entire carbon agenda from the kinds of things that are being done now to keep nuclear open in the US? Do you want to take that first, Michael?
Yeah, I think David, and you've hit on an important point, which is it certainly looks like it's more feasible to have policies that are aimed at particular technologies. Let's call them renewable portfolio standards, subsidies to solar and wind, and then some of these fix-ups we're seeing in some states about nuclear. I think the challenge with those, all of those policies, including the fix-ups for nuclear plants, is that it's a little bit like trying to, I mean, I don't know how good of a pool player you are, but I'm pretty bad. And like the bank shot always makes me nervous. And I have a hard enough time hitting it directly in the hole, but the bank shot is really hard. And the thing is, like, we don't actually care about solar or wind or nuclear per se. What we want is we want cheap electricity, and we don't want to have all kinds of environmental problems attached to it. And when you start going for the bank shot, like, well, I like this technology because, you know, David's from California and people from California like weird stuff, then you don't necessarily get the thing you actually wanted, which was a carbon reduction. In fact, there's some new evidence, even as one example, that renewable portfolio standards may have very little impact on carbon emissions, precisely because they favor these particular technologies and don't take account of the dynamics of how, electricity systems that mean you're going to have to build probably fossil fuel plants to back up the renewables. So I think, to circle back to your question and away from pool, I think once you start directing policy at something that you think is related to the thing you want, but it's not the thing you want, all kinds of unintended things can happen, including not making progress on carbon.
Yeah. David, do you want
I agree with that. I think everybody likes a clean shot, if I can continue the pool analogy. At some point we're going to be interrupted by reality of the actual game of pool. I hope there aren't any ringers in the audience. Everybody likes a clean shot in the abstract until it affects their individual industry or their interests. And then they go for bank shots and a variety of other things. And that's what we're seeing. And this is, you know, not unique to this area of politics. I think, to me, what's interesting is that you've got now competing subsidy and support programs that not only are designed to kind of hide and create all these multiple bank shot effects with these unintended consequences, like in some cases renewables or storage not lowering emissions, but you're also then creating, you're setting up you're guaranteeing that there's going to need to be a bunch of other bank shots made. So for example, by subsidizing variable and intermittent sources and giving them priority on dispatch, we now de facto are creating the need for capacity markets whose design we don't really understand, that are quite volatile. And then we're crushing the nuclear plants for the reasons we discussed earlier about negative power prices. And so what I worry about is not just the distortions being created right now, but when you think about this strategically, a few steps down the road, you have many more hard bank shots that still need to be made in order to keep the system kind of together. And it seems likely it's going to come unhinged.
Well, it also seems to create, from a political perspective, a circular firing squad among low carbon energy sources, right? Because everybody's fighting for the policy that incentivizes their technology as opposed to the one that actually most efficiently leads to decarbonization. Okay, so
and
now,
I do
please.
think that comes back to like a confusion, maybe intentional confusion, on what the goal is.
And I think it's absolutely intentional.
Once you lose sight of, or intentionally or unintentionally lose sight of what the goal is, then you can end up in this kind of weird space.
Sure. So, and then now I'm going to check out your sort of test your economics bona fides, or your sort of true-blooded free market capitalism.
Do you know he's a Milton Friedman professor?
I know. I'm going out on a limb.
I don't think I have to answer
right
the question.
now.
I think you have to.
It's like a small dream of mine. So, okay. So all that being said, let's give a carbon price that you guys have laid out, right? Let's just say, here we go. We've got a national carbon price that makes nuclear competitive relative to what you've just said. You pretty confident we're going to get that nuclear? Is it as easy as that?
Confident that we'll get nuclear then? Mm-hmm. No, the numbers say we probably won't.
But what if you had, so, you know, within the, I forget what the range was for you, but a carbon price that's high enough. What if you had a carbon price that was high enough to make nuclear compete on an LCOE basis, would you get it?
Oh, I think, are you asking, are there other issues with nuclear? What do you want to talk about, shutting down the plants?
Do you want me to talk about the other issues?
The other issues would be good, yeah.
Well, first I could just, I'm sure Michael's going to agree with the first part of what I say, and I'm not sure about the second, but to me what's interesting is you start to put a price on carbon, you know, even $15, $20, $30 a ton, that will have an impact on the existing fleet, especially the multi-reactor sites, no question about that. But it'll also have an impact on a lot of other options. I was in Houston a few weeks ago visiting the Net Power project and the related scrub program on the coal plant nearby. And you know, the economics of these CCS, CCUS projects, they now have a subsidy, but you put into price you put a carbon price of 20, 30, maybe $40 a ton. A number of those projects are going to come in. I think what's really exciting about this, from the point of view of decarbonization, is that if we put into place a carbon price, there's going to be a lot of competition, and it will also establish some credibility that higher carbon prices might come. And I think part of what's going on in the boardroom right now is that people don't know whether to believe all this stuff. And so until they see signs that there are credible moves in the direction of decarbonization, you're not going to see firms investing in projects as the first of many projects. They're going to treat them all as one-offs, and not surprisingly, they're not economic. I think the other issues are around, there's no question about it. We've got a poll that's just come out of the field that suggests the stigma around nuclear is pretty severe and hard to deal with, and if that's true, then that means that SMRs, unless they rebrand themselves as, magic machines or something like that, they're going to have a problem just from the stigma point of view. But I do think there's a tendency to overstate the difficulties, for example, around the fuel cycle. There's no issue we spend more time on in the Senate Off-Rate Community Engagement Panel than the fuel cycle and what to do with the spent fuel that's stuck there. But some solutions are coming into sight. There's interim storage. Real companies are working on deep borehole. Yucca might get open. I don't think that's going to happen. So I think the fuel cycle issues have actually been radically overstated. The core problems are economic and this kind of stigma and political acceptance.
There's one, you mentioned at the outset that I worked in government for 1 year. One thing, and I can no longer remember the exact topic, but the economists had gotten together and we'd sharpened our pencils, and we came up with some super precise calculations of some policy, and the benefits are going to be greater than the costs. And the way it works in government is that the economists do it, and then there's the interagency group, and suddenly the Department of Defense people came in the room, and they're like, well, no, we can't do that. It threatens national security. And the conversation was over. And our very precise calculations were not quite relevant. So what I want to do is turn it around. I don't think any of the people in the room currently were the people who came in and undid my calculations.
But they're watching.
They're watching, yeah.
And listening.
But this relates to nuclear. My friends in the nuclear industry and the defense industry all make the point, to which I cannot be a very reliable judge, that there is some national security reason to have a thriving or at least existing nuclear industry in the United States. And when they start to talk about it, it doesn't sound completely crazy to me. But I'm going to infer from what we're doing that the value of that per megawatt hour is less than the delta between natural gas. But I want to put it on them. Why don't they come up with a number and help us understand that? So should there be an externality charge or subsidy for nuclear to reflect the benefits that it's providing the country with respect to national security? And I don't have a dog in the fight about what that number is, except that it can't be infinite. And that's kind of the way the national security people argue. And I think I can say now they're not winning. They won it in that, I'm getting them back. They won it in our little debate when I was in government, but they're not winning it on nuclear. And so I think having some more precision could be useful.
Okay, we'll ask the third panel to come up with a non-infinite number for us to plug in. So within the environmental community, there's a fairly active debate about whether nuclear is necessary for a deeply decarbonized energy system, period. I think it's a uniquely US-oriented discussion, though other countries around the world are grappling with it as well. I think we're more familiar with the politics of it here in the US. Are they right? Is there a legitimate debate about whether nuclear as it currently exists, or as we've forecast or think about some of the technology cost reductions, is it necessary for deep decarbonization, and at what point?
So we're in the United States of America and we have a market economy. And I just don't think about things like that. That's like a kind of Soviet thing. Like, we're going to get the plan for the next 5 years, then the years 6 through 10, we're going to get another plan, and then 11 through 15, we're going to have a plan, and we're going to decide that today. I think we should let people compete. And if nuclear is above the bar, inclusive of all externalities, that is terrific, and I will love nuclear more than I do now. But if it's below, that's too bad. And that'll be to the benefit of some other technology, maybe that we don't even know what it is. So I understand that the engineers and some of the environmentalists like talking about it that way, but I find it counterproductive. It's not actually how we operate markets in the U.S., so I don't even know what it means in practice. And I think it's just not helpful.
Dave.
Look, I'm totally in favor of competition. I want to come back to the kind of political issue about the environmental community. And first, I don't think there's as much debate inside the environmental community as it seems. There's a few very noisy environmental groups who are making the case for nuclear, anchored in decarbonization, a variety of other things, but mainly decarbonization. But I would say the vast majority of the environmental community is actually dead set against it. And for traditional reasons, and it's true not only here, it's true in Europe. I mean, in some sense, they've had more political success in Europe. You look at the German program, you look at this threat on the French program, and it's pretty extraordinary. So I think there's actually less support there. That's not my view at all. I think it depends on your goal. It's hard to be serious about deep decarbonization. If you believe that climate is potentially existential and certainly a very, very large threat to the planet, you got to be serious about decarbonization, and decarbonization quickly. And that means you've got to look at, high penetration renewable scenarios, which everyone's thrilled about, and you've got to take CCS, CCUS seriously. You've got to take nuclear seriously, and you've got to generate competition, because otherwise, you raise the risk that you're not going to be able to decarbonize, or the costs are going to be catastrophic if one technology doesn't work out for some reason. So that point I just really part ways with the core of the environmental community over.
I mentioned at the outset of this discussion that Secretary Moniz had come in 2016, shortly after a CEAB study had been done about nuclear at a crossroads, and he put forward this idea that for a variety of reasons, 3 of which were fundamentally climate-driven, that nuclear, we had about a 5-year window to make some big decisions on nuclear, or else we wouldn't have it as an option for meeting some of the challenges of our electric power system and decarbonization. Is that right? I mean, do we really just have this small window where we need to make good on nuclear? And we can expand this from the US perspective to a broader one, but or else some sort of ship has sailed, or is that kind of a fatalistic way at looking at something that is like any other technology? It evolves over time, and right now it may not be competing very well, but there could be a set of circumstances where 15 years from now it actually does.
So I was, before he was Secretary Moniz, he was Professor Moniz, and he was my colleague. And I have found it is, I almost very rarely disagree with Ernie. And I suspect that probably what he had in mind was some kind of carbon constraint, and that in the short, relatively near term, it was difficult for him to see aggressive cuts in carbon without nuclear being part of it. But I think more broadly, I think there is a real opportunity. There are some interesting stories of next generation nuclear technologies, which we really just don't know what they're going to cost yet. And I think it would be prudent policy to start investing in a meaningful way and figuring out if they can be part of the solution or not. And at the end of the day, like, the carbon problem is really a problem that the low carbon technologies are more expensive than the technologies that have carbon. And until that is changed, and basic R&D can be a big part of that, this problem it's not going to go away.
Yeah, I mean, this is structurally a hard problem. The decarbonizing is expensive. It affects the interests of existing well-organized groups, and the benefits are in the future principally in other countries. So structurally, it's a hard problem to solve. It's kind of not surprising that we haven't made a lot of progress on it. And then you have options that come along, including nuclear options, that potentially make it easier to manage the costs, and that makes the politics easier. So one of my interests in this is I see a structurally impossible political problem that gets easier through technological change. And I guess just to push on this window issue, I get maybe to paraphrase Bill Clinton, it depends on what you mean by the word window. Okay, bad joke. Yeah.
Everyone's braced. Where are you going?
Yeah.
Where am I going? If it's in the sense of you close a window and then it can't reopen, clearly that's not correct. I think what's happening though is we've got these ratchets. And so every 5 to 10 years where we dither around and we don't do this, we then lose part of the existing fleet, including potentially now some multi-unit sites, which are very low-cost ways of decarbonizing or continuing to have decarbonized energy supply. And that makes then the rest of the problem harder down the road. And so you can reopen the window, but reopening it becomes more expensive, in part because of the credibility problem. I mean, you've got the largest builder of new reactors here has just sold assets to shore up its balance sheet, in part because of the cost of its nuclear building program. And so from the investment perspective, the credibility of doing this is very low. And so you've got to rebuild that credibility, and you've got to do projects and demonstrate how that's going to work, and all that's going to take some time. And that's, I think, probably what's accurate about the window metaphor.
Can I, there was something in your presentation, can I turn back to it? It was really...
If you can figure out how to work it.
There we go. So the purple dots, those purple dots are kind of amazing, which are the overnight capital costs for the Korean plants that were built in the most recently. Are those real? Like,
yeah,
do you have any traction on that? I messed around with it and I couldn't really figure it out.
So I've spent a lot of time on this, and whenever you're dealing with state-connected or dominated firms, you always have the soft budget constraint. You're never quite sure what's real. And I would say nobody on the outside quite knows what's real in Abu Dhabi. But what is real is schedule, and what's totally plausible is that with good engineering control, systems management, and so on, that the kinds of reactors they're building are plausibly really being built at $2,000. I think it's a big deal. And so while our window is closed or open or sideways or whatever it is, I'm not going to go back to the Clinton metaphor because clearly that was not a big success, that the rest of the world is doing this. I think for those reactors, we are probably at the bottom of the learning curve. And I think there are some risks. First, there are risks on the Chinese firms because of operational questions. We really have to see how well that scales up. And the risks on the Korean firms because they're having some problems in their home market. And what we saw in the French program is that when you stop building reactors, you actually have forgetting by not doing, and so costs go up. And that's a big risk. They're keeping costs low because they're building stuff, and if that slows down.
Okay, now one more question. If we were to be honest about these couple plants, that there were one failed and there's some are going ahead in the U.S., where are they? Overnight capital costs? In the U.S.?
We're probably in the 5,000 or 6,000
5,000 or
range.
6,000. Okay.
People happy with 5,000 or 6,000?
Even with the realization, not the ex-ante.
It's better than Finland.
Yeah. Okay.
Well, and it gets back to the issue of, you said it, David, which is part of the argument for keeping the existing fleet and building new of the current generation of nuclear technologies is to keep the human capital and expertise and all of those things, around. But a legitimate question that came from the newest builds in the U.S. is whether or not that expertise is still in fact around enough.
Well, and that question
is
not yet resolved because there's still a final phase. But what Michael said earlier about security is true here. The value of that is not zero, but it's also not infinite.
Yeah.
And so we can't kind of have this debate about keeping all this capacity around, kind of sitting ready to build something and pay at an infinite price.
Yeah. I want to open up soon for questions, but you had mentioned R&D, which is always a huge part of the climate discussion. Part is deploying technologies that we have today, and two is investing in technologies we need for the future. How are we doing in terms of the way in which we spend money in the U.S. on R&D for nuclear technology towards meeting the climate goal, and are there recommendations you have for how we could do it better?
Look, I think what Michael showed is correct on the total spend. With trepidation, I picked this thing up. With total spend, it's not a good picture, and then I think it's even worse.
Go back.
No, I'm going to go. There we go.
Oh, you got one.
So I think it's even worse. This is from a paper we just published late last year in ERL. This is the total DOE budget on the left-hand side, and then we're expanding out the portion of it at the very bottom, which is the energy programs budget. And from that, we're expanding out on the very right side the portion of the energy R&D programs that the nuclear energy budget. And this took a long time and many FOIA requests. Turns out people don't like inconvenient information to be published. And the amount of actual spend on advanced nuclear R&D at the federal level is tiny. More than half of this is overhead. Much of what remains is spent basically on legacy technologies, some advanced fuel, some legacy fuel. And so there's very little at the federal level that's going into this area. Now maybe this problem is getting addressed through all these private companies that are emerging. Some of them with capital that's kind of like hobby capital. You know, rich people want something to do to help the planet, and so they help back a company. And that's actually, I think, becoming a significant part of the U.S. innovation landscape in some technologies. You know, self-levitating helicopters, a variety of other things. But that doesn't seem like a serious program to me. It's a program that comes and goes.
Okay, so can we just this is your slide and I'm hijacking it, but like this is like not being serious.
The slide's not being serious?
No, your slide's beautiful.
Thank you. I'm really insecure about my slides when I saw your slide. Huh? Yeah, look.
Well, whatever. Like, what is, I think the way to, let me say it a different way. Like, what plausible rate of return might you imagine federal R&D spending has? Like, well, you know, maybe it's, in the private market, everyone would be happy if they could have 8% return on something. Let's say the federal government is choosing things for which, due to the appropriability issues, you know, the rate of return is 20%, which would be, you know, astounding. We'd be thrilled to have a 20% return on that. That's 20% against a baseline, if I'm reading your colors right, of like a couple $100 million.
Yes.
And it's, you know, it's the same thing with like ARPA-E. Everyone loves ARPA-E. We're going to invest in the new technologies. I love ARPA-E. Some of my friends are ARPA-E recipients. But, you know, what plausible rate of return on ARPA-E money could you imagine? We're spending $300 million. I'll give you 100% return. Like, that's not, compared to the magnitude of the energy and the climate problem, that's just messing around.
Okay, rather than pick apart your slide further, I want to ask one more question before we open it up for folks, which is, are there any countries around the world where you think they're effectively using nuclear to underpin their low carbon strategy? And if there is, are there any lessons that we can learn from that experience? I mean, there are places that are building a lot of new nuclear capacity. China is clearly one of them, but would you say it's sort of the underpinning of how they're thinking about decarbonization writ large? And saying that from the perspective of, you know, a lot about the climate change discussion in the near term is about bending the curve, but as soon as you get past 2050, it's really about fundamentally changing the electric power system and all of the rest of the economy as well. I mean, is there a country that is really embedding nuclear into the core of its low carbon strategy?
I don't think so, but I don't think there are almost no countries that are actually doing low carbon strategies. For most countries, I'm sorry, this is kind of a debater trick here, but most countries are getting, and that's totally reasonable because this looks expensive, nobody's quite sure what to do, and most countries are not willing to spend a large amount of their own resources for what is seen as a global public good yet. That'll change, hopefully, as people learn more about the problem and so on. So you've got the countries that are already that are spending a lot of their own resources on the problem, and they're in Japan, which could have at least the restart as part of its strategy, but the restart hasn't yet happened for reasons that are well known. And you got a lot in Europe and the coastal parts of the United States, and that's kind of it. There are countries that are doing a lot with nuclear reactors, China, Korea, China less than they are on renewables, but it's not principally for carbon reasons.
Yeah.
And so I think we're not, I mean, this goes to the point as the political support to do something about the problem gears up, which I hope it will continue to gear up, that right now, politically, the solutions that garner the most support, especially across ideological lines, are principally renewable solutions, and they need to be part of the equation. But there isn't yet really decarbonization as a lot. Yeah.
So can I do a little more I'm not going to answer your question because I don't like it too hard, but I'm going to answer a question I like better.
Okay.
Are there decarbonization policies? Yeah, there are. The EU has a carbon trading program. There's a price on carbon. Is it that high? No, but it's directly on target. Canada is I guess it's getting a little bumpy, but it's supposed to have a price on carbon throughout the whole country, I think, January 1st.
Yep.
And I think the latest estimate says that 15 or 20% of carbon emissions around the world actually face a price, be it through a cap and trade or a tax. Now, is that price at the level of the former U.S. government social cost of carbon? It's not always that high, but maybe never. But it is, it is not impossible. Yes, people love their solar panels and people love their wind turbines, but I don't want to be too fatalistic about it. And I think, again, if we come back to what the goal is, which is low energy prices and try to minimize externalities in the process, it's a simple economics problem. And a lot of countries, or a lot of places in the world are actually winding, serpentine way getting there.
Great. Okay, we're going to take questions. I need your name and affiliation, question in the form of a question, please. I'm going to start right over here with Bob. I might collect a couple. Are you guys okay? Sure. Okay.
Bob Rosner, University of Chicago. I just have a two-finger correction, which is there is a country which does use climate issues as a justification for the nuclear policy, and that's Sweden. Sweden does not use fossil fuel to produce electricity. It's about 50% nuclear, 50% hydro, and they recently made a decision to maintain that fraction. And that decision was based on climate considerations.
Thank you. Okay. I'm going to collect a few just because I think we'll have a bunch. We're going to do, well, for mic purposes here, and then over there, please.
Thank you very much. Paolo von Schirach, Global Policy Institute. Back to the first set of slides you showed us, which obviously make a pretty compelling case about the cost effectiveness of nuclear versus all the other forms of electrical power generation if you factor the externalities. The fact is, here in Washington, D.C., the externalities are never mentioned. It's not part of the policy discussion. I mean, maybe among the experts for sure, but in the general political debates about which sector should we favor or not favor, et cetera, this is never mentioned. We are still in an environment in which we're saying we should reopen coal mines in West Virginia because that's about jobs and all that. So how do we make those considerations, which are very sobering, part of the real day-to-day debate that should influence policy choices and our understanding of the relative merit of nuclear versus other modalities to produce electricity, including the much beloved renewables that, as you pointed out and many others know, that carry hidden costs to them. How do we get there? We're not there for sure.
Thank you. And we'll take one back over here. Raise your hand. Yeah.
Yes, Robert Lanza from ICF. I was at a talk a few years ago, and somebody mentioned the Santa Fe nuclear plant and commented that part of the rationale that activists were talking about closing that plant was those nuclear megawatts were standing in the way of renewable megawatts, and that was the perception. Not coming from California, I wanted to ask whether there was anything to that, and larger question as to how renewables, quote unquote, defined versus the decarbonization objective that you were talking about. Thank you.
Okay, we'll take those two, and then we'll try and do another round if you guys are speedy. Okay. Want to go first?
I'm sure Michael wants to talk about how you get externalities on the argument, so I just want to talk about the San Onofre one. So in the San Onofre case, the power was largely replaced with gas, not renewables, although the deal to close Diablo Canyon, which is the PG&E plant, is a deal that's essentially wrapped in renewables. I see very little merit to the argument that the nuclear is standing in the way of the renewables, but I can completely understand that the politics of the problem, it's not framed that way, and this is a huge problem. And I think actually, one of the characteristics of some of these smaller reactors might be to operate in load-following mode. There are many reactors in Europe that already operate in load-following mode, and so that's not kind of rocket science, and I think that would be important for the political debate. Let me just add, in addition to Sweden, so in the Swedish case, the decision was not to implement the policy to phase out the reactors, and I think the great test will be France. Because if the French actually carry through with the policy to close the reactors, that'll be a big setback in the arguments that we've been hearing today. And if they keep them open, that'll be the high water mark for a nuclear-driven low carbon strategy.
Yeah, so I'll take on your excellent range of questions there. So the first thing is, one reason that at least the carbon externality is not mentioned currently, I think, is that the current administration has not embraced the notion that CO2 causes climate change. And so that obviously, if you don't believe that, it's going to be hard to enact policy that aims to rectify that. But if you want to take a slightly longer view, I disagree. I think, the Obama administration was filled with mainly regulations, but nevertheless they were impactful on carbon emissions that directly targeted carbon emissions and treated it as an externality and priced it at the social cost of carbon. So I think there's some hope there. I'll also add, snuck into the tax bill, which I think most people don't realize, is a $50 a ton CCS credit, which coincidentally is the former US government social cost of carbon. President Trump signed it. I'm not sure he read that part, but so that's an example of the externality being recognized. Now, I think your broader point is, why isn't there widespread enthusiasm or acceptance of the idea that there's climate change and it's related to CO2? And I don't have a great answer. I have an operating theory, which I'm trying to test, which is, I think, when you talk about climate change altering global mean temperatures by 2 degrees C, so, first of all, I'm a product of the Chicago Public Schools. Like, we didn't learn C. Most people don't know C. So that's already a strike against the enterprise. And then you talk about, well, global mean temperatures. Well, that includes the oceans. So I don't, do I care what happens over the ocean? Maybe I should. Maybe the scientists tell me I should. I just think it's not being communicated in a very meaningful way. And so my operating theory is that if both the physical impacts and the economic impacts can be localized, and you can talk to people, and people can see in my community what's going to happen to energy demand, in my community what's going to happen to crop yields, in my community what's going to happen to mortality, that may be a more effective way.
It's moving that way, I think. It's pretty extraordinary in climate impacts. I was at the Del Mar City Council on another matter on Monday, and the place was crawling with folks because they're now grappling with what managed retreat might mean for sea level rise. That's very local, very serious for property owners.
And you should put a plug in for the Climate Impact Lab if you want to. Right?
Yeah, I'm happy to plug the Climate Impact Lab, which I help lead, which we're trying to do exactly that. So.
That information.
Sorry, it was implicit, but
okay.
I should have. I'll get a slide.
All right, we'll do one more round of questions. Yeah. Was there one in here? Okay, will you, sir, and then you, and then you.
My name is Sam Miranda. I'm a retired nuclear engineer. 25 years experience at Westinghouse designing nuclear plants, including those with load follow capability. By the way, they all have load follow capability, they're just not used. And 15 years at the NRC regulating commercial nuclear power and reviewing naval nuclear propulsion reactors. So we're talking about renewables, and from my ancient history, I recall that the first reactors were designed as breeder reactors. The first commercial reactor at Shippingport was a breeder reactor, 93% enriched uranium with a blanket of uranium-235, and it did breed plutonium. And then there was the Clinch River reactor. So how does that renewable figure into your calculations regarding renewables versus nuclear power as an alternative. And in addition, also related to that and related to nuclear security and proliferation, I would bring up the issue of spent fuel reprocessing and also the use of plutonium removed from nuclear warheads to form mixed oxide fuel. And finally, the second point that I saw for industrialized economies was the problems were political as opposed to technologies for the emerging countries. So one of the political issues is the rejection of fuel reprocessing, which some countries do. That's one. And the other is the Nuclear Regulatory Commission itself, which was referred to earlier as a gold standard, and which today is a captured agency with only 3 of 5 commissioners in office.
Thank you. Okay. Tom, right here. Just put your hand up again so I can find you. Thank you.
Tom Cochran, and I'm too old to work, so I'm not associated with anybody. I have a question for Michael and a question for David. For Michael, has anybody tried to unpack the difference between the AP 1000 costs and the Korean costs? For example, is the AP 1000 costs associated with bad design by Westinghouse coming out with it to get the subsidies before the design was complete, or was it mismanagement at the site, or was it because we don't have a heavy parts plant, nuclear parts plant in the U.S.? And for David, I remember in 2003, MIT economists were telling us that what turned out to be the AP 1000 was going to cost, overnight cost of $2,000 a kilowatt. And I remember the University of Chicago telling us how cheap the small modular reactors were going to be because of factory manufacturing. So why should we listen to economists from either MIT or University of Chicago? You can see why I didn't ask David. I mean, why I didn't ask Michael.
He's a corrupted witness.
Okay, and then we'll do Bob, and then we'll...
Thank you. Bob Eichhorn, Atlantic Council. One comment and then a question. It seems to me, in looking internationally, that this tension between trying to develop competitive energy and power markets and the environmental interventions and policies are a real factor here. And clearly that's been the case as we looked at competitive markets in the U.S. and how to reconcile those with environmental policies. In terms, since the session's on environment, I wanted to ask about sort of environmental policy approaches and instruments and how you view those. Because, I mean, obviously, and Secretary Moniz yesterday was talking to the nuclear industry down in Atlanta and supported the Baker Schultz-Polson, carbon tax, Republican alternative. And but David, you're being in California, clearly the issue, you have a emissions trading system there. Is it working? How do you view the two? And then we've got zero emissions credits now that states are imposing that are a different form. And of course, we've seen on the renewable side, we've had tremendous impact from the production and investment tax credits for renewables. So lots of intervention at different levels that have affected this, but in terms of the basic environmental policy approaches, what's your thoughts on that?
Look, I think this is a very important point. There's a real tension here because the politics favor shifting costs of programs from people who are well organized to people who aren't organized, and that's frustrated by everything we love about market instruments, which is their transparency and their competitiveness. I am very dark on cap and trade programs. I think every significant cap and trade program in carbon, maybe with a couple partial exceptions, is designed to be a Potemkin market, to look like it's creating a shadow price on carbon. In fact, what it's doing is trading a residual that's left over after all the other policies that are a lot more expensive have their impact. And so to me, it's encouraging when you look at, for example, the World Bank carbon price.
So wait, hold on. Why does that make you, we have to have a little friction here. Okay. So why does that make you negative about cap and trade markets? It should make you negative about the goofy policies inside.
Right, but that's
cap and
precisely why. So I used to think that it was, if politicians would just get rid of all the goofy policies and just have cap and trade, absolutely. But instead what's happening is by design, you have all the goofy policies whose costs are hard to pin down, and that's what makes them politically attractive. And the cap and trade program allows you to tell everybody that the marginal cost of compliance is $12 a ton. When in reality in California, the marginal cost of compliance is probably $50, $60, $70 a ton. So I think that I think this is an important debate to have, which is to whether the political economy.
I think you're hating on the wrong thing.
Maybe. But the nice thing about a carbon tax is that regardless of the goofy policies, you do get a clean signal at the margin with the carbon tax. And I think it's encouraging that the places that are doing the most, Sweden and Norway, for example, are doing it with carbon taxes at the margin. And so that I think is pretty encouraging. I think you were joking about whether we should believe the economists at all, but I will say hopefully something serious about this, which is we don't know. The guy's lead author on this paper, Ahmed Abdullah, led an expert elicitation around SMR costs, which suggests a kind of ugly picture, but we don't know. And so I think there's been a tendency to just assume that once you build more of these things, costs go down. That's true for some technologies and not for others, and you just don't know ex ante, and that's one of the reasons why competition and decarbonization is so important. And I just want to make one brief defense of the Nuclear Regulatory Commission, which is not a role that I'm usually in. I think we need to cut them a little bit of slack. They've actually done an extraordinary amount of work to be nimble around licensing of these interim storage facilities, to grapple with the new small modular reactors. And you may not like exactly what they're doing and think they're slow and so on, but within the realm of a real agency that has real political accountability as opposed to an imaginary agency that can solve all problems instantly, it seems like they're actually doing a pretty good job.
Michael.
We're going to have to find some things to disagree on.
You like University of Chicago economists?
Yeah. Well, I liked MIT when I taught there, but now they get everything wrong. And the University of Chicago is really coming into its own. But no, I think to the question, I get it. Like you could bring in any economist, and they're going to say that we should just have a clean carbon price and be done with it. And the political reality of that is that that's not really where the world seems to want to go. But I don't think it's such a freebie to do these kind of bank shot policies. I think the fact that we're not engaged globally in very serious carbon abatement is a function of the fact that those policies are expensive. Sure, we're going to do some of that, but I think our willingness to take on a lot of it is pretty limited. And when you go to the supermarket, if you can buy a tomato for $10, or you could buy a tomato, or buy 20 tomatoes for $10, most people take the 20. And right now we're choosing the one tomato for $10.
I'm not sure we're going to let you into California with that kind of attitude.
Before we go, I want to just point out, I think one of the interesting analogies between the first panel and the second panel is everybody's looking for a driver for getting serious on nuclear within conversations about whether nuclear can compete. And the first panel spoke about just getting serious about being competitive, right? Having a bit of an industrial strategy. And I think a lot of the carbon argument for nuclear is quite similar, which is if we just get very serious about decarbonization, right, there may be a price high enough that would incentivize all the kind of changes that we need to see. And yet neither one of those things is clear that there's either the straightforward economic rationale or the straightforward political economic rationale to make either of those things happen. I hate ending being kind of like, a gloomy person. I get accused of it quite a bit, actually. But so if you were to feel, whenever someone says to you, look into your crystal ball and look at a low carbon future, you have a rank order in your head of, technologies that might succeed. What would be one of the most important things to change the way nuclear factors into that equation for you and you're looking out for? Is it a policy? Is it a technology? Cost shift? What is it? We'll start with Michael and end with David.
What would be, so sorry, I'm not quite sure if I followed the question.
What's the signpost you're looking for
For nuclear
For nuclear
future?
to factor better.
Yeah,
in
I
renewable
don't want to answer that question. I don't care about nuclear. I care about the cost of electricity.
That answers the question.
And externalities. And if nuclear can get us there, I love nuclear, but I don't love it any more than anything else that could get us there. Subject to the national security considerations, which I think are very important. Yes, as long as they don't get to call infinite on that.
Michael loves all of his low carbon children equally.
That's right.
You can choose one over the other.
Sophie's choice.
I think I agree with Michael's answer, but let me try and answer your question nonetheless, with the caveat that it's unanswerable. I think clean signal about decarbonization, which is a policy point, is really important. There's a real tension politically in this issue. On the one hand, this is a global public good problem, which tells you that you've got to have all jurisdictions cooperating. On the other hand, since nobody really knows what to do, and they're risk averse and politically risk averse because these policies affect existing organized interest groups, leadership's really important. And so, ironically, I think the more we're going to make more progress on this problem as we have more leading jurisdictions that go off and kind of demonstrate, okay, here's how you do a $50 carbon tax. Here's how you recycle the revenue so that people don't kill you politically. Here's how you do a nuclear program, or what Norway's doing now with CCUS and CCS, to start to demonstrate stuff. And so even though those leaders are a tiny fraction of global emissions, their impact is on followership. And that's, I think, the real tension here, is that we've been thinking about the problem too much as a global public goods problem, which has led us to imagine that everybody needs to be making policies in lockstep. And in reality, those policies are mostly not possible until you demonstrate viable political paths forward.
Great. Okay, well, I want to say thank you to Michael and David, and I want to ask you to join me in thanking them. But before we do, we're going to let you go for 15 minutes. We're not, awful, so we can get coffee, reset, and then come back for the next panel. But thank you guys very much. This is a lot of fun.